Day 3. Gear Ratios. You and the elf eventually reach a gondola lift station. He says the gondola lift will take you up to the water source, but this is as far as he can bring you. You go inside. It doesn't take long to find the gondolas, but there seems to be a problem. They're not moving. Ah! You turn around to see a slightly greasy elf with a wrench and a look of surprise. Sorry, I wasn't expecting anyone. The gondola lift isn't working right now. It'll still be a while before I can fix it. You offer to help. The engineer explains that an engine part seems to be missing from the engine, but nobody can figure out which one. If you can add up all the part numbers in the engine schematic, it should be easy to work out which part is missing. The engine schematic, your puzzle input, consists of a visual representation of the engine. There are lots of numbers and symbols you don't really understand, but apparently any number adjacent to a symbol, even diagonally, is a part number and should be included in your sum. Periods do not count as a symbol. In this schematic, two numbers are not part numbers because they are not adjacent to a symbol. 114 top right and 58 middle right. Every other number is adjacent to a symbol and so is a part number. Their sum is 4,361. Of course, the actual engine schematic is much larger. What is the sum of all of the part numbers in the engine schematic?
So I just got done recording, but it turns out that actually my audio was corrupted. So actually it was pretty much a silent movie for everyone there. So I have to re-record it. So sadly, I do actually already have the puzzle for part 1 and part 2 already completed. So I know ahead of time what's going to happen. But I think it's still important for me to go over this and share my knowledge around how we can actually combat this challenge. So pretty much what I'm going to show you is pretty much the exact same as what I did, and I think I wouldn't have picked it any other way. So let's start by breaking down each of these problems. So the first thing that we need to do is we need to generate a sum of all of the part numbers in the engine schematic. So of course, how to get these part numbers? And part numbers are numbers adjacent to any symbol. So in the case of this first one, 467, that's one number, and it's adjacent to this star. This is actually diagonally, so there's actually a requirement around this. It's diagonally across, but also this 33 is as well. So we need to make sure that these two are included in our list, or that is our part of our sum. The next thing is to note that some are actually not included. So this 114, for example, there's actually not a symbol next to it. This is going to be the diagonal across as well. So there's actually nothing. And dots don't count towards it. So let's start off by creating, let's say, our output, or we need to parse this information, this data, so we can actually do some lookups and scan across our code. So across our input. So I'm going to create a structure called engine in this case. And let's say that this is called, for example, we're going to have a list of numbers. This will be a vector of numbers. This will be used to store every single number. So as we build up an index of all of our stuff, so we're going to run through one phase, which is build up all the data. And then we're going to use another function to kind of scan through the well. So what we can do is attach some derived macros to this. I'm going to add debug and default, like a default because it makes it easier. We also need the same for our number strut as well. This is really helpful. For number, it's a little bit different. We need the value of the number. So if you can imagine, this will be our 467, for example, that we can parse later. We also need the row, so the row that it's in, so 0, 1, 2, etc. So this is an important number to have. We're going to do that as an I32. Now, there's two choices of how to store columns. The first way that I would have gone around was actually around using, instead of just having a column that's a single column that's an I32. This can be good. But there's actually some limitations of this that I would be considering. The first time I did this, I might have been hey, maybe we should use an I32 here. But I realized quickly that actually when you look at each of the symbols to say, hey, is there any numbers around it, for example? Or if you do it the other way where you look at each number and see if there's symbols around it, it's actually good to have an index of all of the all of the locations where your number is. So I'm actually going to make this a vector of I32s, so it makes it a bit easier. One of the main other reasons as well is that when you do like, is this position in this number, for example, you can just do a like column dot contains. And then the last bit for the engine is we want all the symbols as well. So as we parse all the symbols, we also want them. We want well. I'm gonna do a list of or a vector of probably just rank positions. I actually like to use like just a standard type when I do certain things like this. So I'm gonna call it point, and I'm gonna make this a a point is just tuple of two I32s as well. And then we can just do here. You can use just set it in here as two I32s, but I think that's actually not. I'm just going to call it point and leave. So fantastic. So we have these symbols, we have these numbers, nothing's happening so far. So first things first is we need to create this mutatable engine. Let's say, let's create one engine, use default. Just makes it a bit easier. So it's just like it applies all the stuff for us. And then of course we want to start feeding in that input. So I'm going to create a function. I'm just going to part of this engine. I'm going to call it build just to make it really easy. It's going to be a mutatable reference to self, and it's going to take an input, which is just a in our case, and it doesn't need to return anything. So if we do a quick there, we can also do an engine dot build. The other thing that you could do as well that's nice is maybe this should return like an error, just so if you don't need to have say any unwraps, for example, or something in here, but we don't really need that, so we'll just leave it as it is. So we now need to build this index of stuff. So we need, for example, all the numbers and all the symbols. So let's do that first. Let's say that we want to create, for each row, we want to have a specific line, and we want to take each of the lines input here. Oh, that's not correct. There we go. And we actually want to make sure that we capture this row. This is actually a really important row to know. I'm actually going to move this over here. Well, this is actually a really important row number to have, because when we start putting numbers and symbols in our engine, we actually need to make sure we capture all. And it's the same for things like the column as well. So we need the column as well and the char. So what we're going to do is now take the line dot chars dot enumerate as well. So right now, if we, for example, print line this, for example, we can also do like row, and then here we do a one and a column. We just print line that. We'll actually start seeing that. We'll be able to actually see all of the different things that we're in. Like we're scanning through every single line and character in our input. Fantastic. So the next thing we need to start doing is actually parsing and looking at the conditions of this. So let's bring this back over. So we need to look for the base case, which is if it's a number. So if the char is numeric, we saw this the other day. If this is numeric, what we need to do is then, like, actually, this is a good point, actually, is that if it's numeric, we need to actually store a list of these numeric values. Now, you could use a vector or something like this. Could be easy. I'm actually going to do it even lazier, and I'm going to create a mutatable number that's just a string, just an empty string. Oh, there. So I'm going to create this number here, and I'm actually going to just push our character, our char, onto this stack as well. So every time there's a number, we're going to push it onto the stack. So that's kind of our base case. The next case that we'll actually look into, else if, is that if the character, make sure that some of the, like, we don't actually care about it. So in our case, like the dots, I don't know if there's any other characters that might be we don't care about, maybe something like alphanumeric or something like that. we can actually use a lot of these functions to find, there you go, alphanumeric, fantastic. Or actually it's an and here, and it's not a, for example, just a dot, right? The period, we don't also want the period as well. So this means that when we hit this clause, it's only going to be the symbols that we care about. And of course, if there's other things we need to exclude, we can also add this here. But what we can do is now do, we can now do self.symbols dot push, and this needs to push a point. So in our case, it's going to be the row and the column. Now, actually, if you try and compile this, this will actually fail, and it's because actually these are not the correct size. So these are actually U sizes that come out of this, and we actually need I32s. So you can just quickly cast them using as that, and bang, that's it. That's it, done. Now what we need to do is handle the case where we've finished. We need to go to the end where we've hit maybe another symbol or something like that. Like, for example, we've done the 4, 6, 7. We hit all these things. We hit the symbol. We need to have an edge case where, for example, we hit the end and there's nothing else coming. Like, we're not parsing any more stuff. We need to then create a new number. So let's take a case here where we're doing, if number is not empty, here, we want to create a new number. So we could do like, let's create a number or something, or blah, 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 blah. The only thing we need to do is actually add a continue here. This is actually really important because if we didn't have this, this would just hit this empty and then cause issues. That's fine. What we could actually do here is we can actually push straight onto our numbers. Ambers dot push. And we can actually push a number. The number needs value. So in our case, it would be the actual number itself. We need the row. So in our case, we just use the row. Of course, we're going to have the same problem where we need to add an I32 here. And then column. This is actually where the problem is going to be. And actually, I've just realized that's column. And if I don't add a plural, bother me. So columns that it's affected by. Let's go back down here. So columns. And one thing we may actually want to do is we could just add, for example, a vector now, or that should work. This is great, but we can just clone that. That's actually, no, I think cloning that would work, but we do actually need to reset it as well. And I believe, if I'm not wrong, resetting it in here. So if we did a number equals a new string here. So we're just resetting this afterwards. We don't need a clone if I'm not. This problem is because semicolon. Do that. Yeah, so we don't need a clone there because it's actually being reset. That's all good. So now we have to create this column. Or these columns, sorry. So we need to get a list of columns. Let me just across nicer for me and for home. So columns here, we need to be able to generate a list of all of the columns. Now, this can be done in a few different ways. The way I would do it is actually using a vector of I32s as the results. So that's what we want as kind of our, what we want to generate. And I'll spacing here. There's a few ways we could do this. The first one being is actually using the iterator. This is like the best one that I really like and really enjoy, where we can actually do something like column.column, sorry, not column length. We want the length of the number. We need this. Oh no, we could do here, where we do number dot length, but it's also column plus length. This will actually iterate and create a kind of a range for us to go and iterate over. We can map over this because if we've done this before, where this is actually a U size, and we actually need to convert that to an I32. And then we also need to run a collector. Well, if we save this now, we'll actually take a look at it. Okay, it's maybe doing something. Let's actually go down here and add a few print statements. Well, something that I actually learned the other day by watching some other YouTubers is actually you can use this syntax to really help pretty print a lot of stuff as well. So we can actually do this, and this will actually pretty print it far better out for us. We can see here now, it's giving us all these numbers. Let's actually check the input. Could use some unit tests that, but it's so. We can already see there's a problem. Number here, we got columns is 4, 5, 6, but actually it is 0, 1, 2, 3, for example. So we're out by a little bit. So let's go back and have a look at what problem. Okay, I know what the problem is. So the problem is that the column, when we hit this case, we're actually on the end column. So we're like right at the end. So the column is actually, for example, we remove this bit. So this is actually the end where we want to be. And this is actually where we want to minus the length of the number. Case. So if we do that now, we'll rerun it. Look. And 1, 2, 3. And if we will double check the other one, which is 5, 6, 7. So 0, 1, 2, 3, 4, 5, 6, and 7. Fantastic. So that's already done for us. Easy. So we've created the columns. That's all nice and straightforward. We're creating the rows. We're resetting it. I believe that's almost everything done for the building side of things. We're pushing all the symbols and everything. We've got everything. Okay, fantastic. So the next phase of this is we want to actually create a scan function. So this is actually the function that will get us all of the stuff that we need for our end results. We need a mutable reference to self. We don't take any other input in here. This is mainly just because we're looking at the input that's already stored in our engine. We're actually going to iterate over each of our symbols. So symbols, or symbol, I should say. And we want to look at symbols. This is actually going to return us a tuple. I actually would like to make that a little bit easier, so we'll call it row and column. There we go. And we'll add a quick print line in here so we can actually see this working. We'll row, colon, colon, well. Oh, okay, yes, of course. Be a reference. Excuse me. Okay, fantastic. We're not actually calling this function, so we'll run it after this, which is a scan function. This will now start spitting out a bunch of stuff. So we've now found 1, 2, 3, 4, 5, 6 symbols. That sounds about right. So fantastic. We'll take a look at now the next part where we want to start iterating over, or let's say we need to start looking at a specific symbol. So in our case, row 1, column set 3 in our case, and we need to be able to look at all the things around it to make sure if it's a number or not. So that should be relatively straightforward. We can actually use some really powerful things, at least in Rust. I think it's present in a lot of other languages. In like Python, there's ranges and other things. But what we're going to do is actually iterate over, we're going to iterate or create some ranges around our symbols. So in our case, we're going to have an X where we want to go from -1 to 1. And we want to do the same for Y as well. So we're using this as kind of similar to hey, we're going to add this to our like symbol row and symbol column, and it will be like adjusted to exactly where we want. A quick note on this as well, when we do this in Rust, actually, if you run this, the thing to showcase as well. If we run this, so X and Y, add a couple of we'll actually notice something. What we want it to occur here is it will look for like 0, -1, -1, and then it should be -1, 0, and then it should be -1, 1. This is something that I've noticed in Rust where actually it doesn't go up to this one. It actually it goes up to but doesn't include. You can actually add this symbol here. You can also do a 2 here. So if you rerun that, technically now you'll start seeing the 1 pop up. Here's a 1. Oh, we're gone. On this one, 0, 0, 1, 1, for example. Or I think the better syntax is actually adding an equals here. And what this will do is like it goes up to and includes that value. And now we can see the ones on both sides. Fantastic. So we can just remove this for now. We need to also adjust our like lookups. So in our case, it would be something like symbol row, which is equal to row plus the offset, in our case y, and the same for sim column, which symbol column is column plus y. So this will give us just the readjusted x and y values. So in our case, if we now look at, here we go, symbol row, and the same for symbol column. Now what we should be able to see is these are readjusted. So they're not actually the minus to 1. This is actually now adjusted for that. So we can remove this for now, leave that. We don't need to print it off. So now what we need to do is iterate over each of our numbers and filter or look up those specific things. So in our case, what we'll do is self.numbers. We want to iterate over this, and we want to actually we used this the other day, the filter function. So we take in a number, it needs to be a reference to a number, and we want to apply a specific filter. So in our case, we could do n.row is equal to synth row as well, or symbol row. And also, we need to make sure that the column is correct. Now, this is actually something, and we thankfully had the foresight to actually add columns here. Otherwise, you'd have to add a little bit more complexity to this, but still can be achievable, which is if you can actually use the dot contains function. So we can actually do columns dots contains. We can actually provide it with n. I think this has to be a reference to n. Is that not correct? No. Is that fine? I think that's correct. No, that looks okay. So maybe we'll just continue on and see. So here we still take the number in, and we want to do something with this number. In our case, what we need to do with this number is actually insert it into a table. Like we need to be able to store this content for us, so we know which of the numbers. Now, so which of the parts? Sorry. Now we could do this in a bunch of different ways. I'm actually going to do the really simple and straightforward, which is actually create a new like parts vector. But one thing I did notice is that if you look at these numbers, the way that we're scanning through this, what might happen is we might go from this point, we might scan this and go, yep, we need a 1. This 35 is actually part of this. But if we also scan this, it may reoccur. So we actually need to use a hash set here just to really make sure that nothing is also introduced. And we can call this a number as well. So all the parts will be stored in this hash set. So it's only occurring one time anytime that we do. Fantastic. So that means if we go back down to our for each statement and we go in here, and for each of these numbers, what we can actually do is, and I've just realized what the problem is. And contains n. Contains symbol column. That's why we're having a problem. There we go. Okay, that makes more sense. I was like, that should work. Okay, that's fine. So what we can do with this n now, so this n is a reference to a number. We can actually add this to our parts. So in this case would be just a push. I always, why is that? Insert. Stuff.parts to insert. Public. These aren't public. Let me fix that. Just, I don't always recommend to put things public, but it's worth adding. So here we add public to both those. Fantastic. We go back down here. We want to insert number. Let's have okay. So the reason why we can't insert this is because actually hash sets have some specific requirements. The first thing is that they need to be a hashable strut. This is just a macro you can add to derive macro that you can add to your strut as well. And the other thing you may notice at the bottom here is it also needs partially equals as well. So we can add both of those, equals and partially well. Once that's done, that should be good. Let's jump down and see what problem is. Okay, this is a reference of reference of this number. There's a few things we could do. Um, I think we're just going to clone this. I think that'll be the easiest thing we can do. This would make it really forward. A number needs to be cloned. Let's add that now. Nothing else should need any of these derived macros, which again, yep, okay, that's finished and fixed all of those problems now. So if we now go down and print the symbols here, engine.symbol. I'm actually surprised we were able to access numbers, but oh well. So if we do symbols, okay, it's found a ton of symbols. Not that many. 1, 2, 3, 4, 6. That's what we talked about earlier. Fantastic. We've scanning this now. So let's now, after the scanning, let's do a quick something similar to this where we're doing engine.parts in here. Let's go here and see what the output is. So it's specifically only these ones. So what we'll do is we'll scroll up a little bit and see if 114 is included. So in this case, it's 33, 467, but no 114. So that's worked there, a treat. So then now what we need to do is actually just create a sum of all of these. Really straightforward. There's probably a few ways of doing this. I'm just going to do it the most basic way I can, which is you could probably sum them together with a map. I'm going to be even lazier and create a total, and then just iterate over each of the parts. And of course, we could have stored, instead of storing all the stuff, we could have just stored this number here. But what we're going to do is total parts, or parts, total amount of parts. We're going to then just do a part dot value dot pars. We need to also provide it with what we're casting it to, parsing it to. In our case, it's going to be an I32. This also needs to be unwrapped. This is something that I've started to really remember now, which is really nice. But this also needs to be unwrapped. We're pretty certain it's going to be a number. That's going to be fine. And then finally, what we want to do is print this total number. And we're going to print this total. We'll actually add a quick total in here. And also save that, let that run, and we will produce a result. And is that the same as the sample example? Yes, it is. Okay, fantastic. So let's run it on our main code, in our case full, rerun that, and we get, a different number. So this is not correct. So let's have a quick look. Why is this? So this is very straightforward and simple. It's probably not this lookup. It's probably something else. Let's have a look. It most likely is to do with the building of stuff. So maybe there's a specific edge case that we're not hitting or not catching when it comes to building it. So let's have a quick look at this input. So okay, that's all fine. Numeric, continue, alphabetical. Hang on. So how we're looking at this numbers, because it's probably to do with this part here. This all looks good. We've already tested this. But something I've just noticed is this is actually inside of our column, because we need this column value to be here. But what happens if this number is actually on the end? So as soon as it hits the end digit, so if there's this 5, 8 was actually moved over by 2, or by 1, I should say. So it's 5 here and 8 here. What happens when the 8 hits the end? It's just going to reset it and not actually include it. So we could do this a couple of different ways. I'm actually going to do it the laziest way, and probably the one that you wouldn't do in production code. But we're going to actually add this and we're going to strap a couple of, just to make sure that we don't have any problems with like the first number as well. We shouldn't have that problem. But what we're going to do is actually create a OG line and a new line from this. And of course, we need to actually call this G, so the original line. And yes, we need to use the to function as well. And that should fix the problem. And it's generated a new value, 512,700 and 94. And that's the same value we have here. So that's the end of part 1. Let's move on to part 2.
Part 2. The engineer finds the missing part and installs it in the engine. As the engine springs to life, you jump in the closest gondola, finally ready to ascend to the water source. You don't seem to be going very fast though. Maybe something is still wrong. Fortunately, the gondola has a phone labelled "Help," so you pick it up and the engineer answers. Before you can explain the situation, G suggests that you look out of the window. There stands the engineer, holding a phone in one hand and waving with the other. You're going so slowly that you haven't even left the station. You exit the gondola. The missing part wasn't the only issue. One of the gears in the engine is wrong. A gear is any star symbol that is adjacent to exactly 2 part numbers. Its gear ratio is the result of multiplying those 2 numbers together. This time, you need to find the gear ratio of every gear and add them all up so that the engineer can figure out which gear needs to be replaced. In this schematic, there are 2 gears. The first is in the top left. It has part numbers 467 and 35, so its gear ratio is 16,345. The second gear is in the lower right. Its gear ratio is 451490. The star adjacent to 617 is not a gear because it is only adjacent to 1 part number. Adding up all of the gear ratios produces 467835. What is the sum of all of the gear ratios in your engine schematic?
So moving on to part 2, now let's break down these requirements as well. And same problem as we had earlier, we finished the puzzle, but we need to get to this number as well in our code. So let's go back over this. So the first thing we need to look at is the end result. So in our case, it's going to be the sum of all of the gear ratios in our engine schematic. We're going to use this first example back to using the part1.txt here. So that's back to that original value. We need to be able to sum all of the gear ratios together in our schematic. Okay, how do you generate gear ratios? In this case, it's actually to do with finding every gear. In this case, it would be the star symbol, and actually taking this value and any adjacent 2 number pairs or parts will have to be multiplied together to actually generate this gear ratio. So in our case, it would be something like this 467 needs to be times by this 35 to give us this 16,355. Okay, easy. And then all of these values that created, we need to just sum them together and produce the result. So let's get started. So the first thing that we need to do is actually create a list of all of the gear ratios. So what we need to do is actually, as we're building this, do we need to change how we build this code? So this actually could be beneficial for us to do this a couple of different ways. The first one being that we actually don't know each of our symbols that we've been pushing to the stack. We don't actually know what type of symbol they are, right? We only know the position of the symbols because we didn't actually care about this. If that's the case, what we could do is actually add this to our type. So in our case, they're actually chars, and we can actually add this to our type. Of course, this will start breaking things, but we can add actually this char as part of this. And this means now that when we scan, we actually have this char available to us. In this case, this column, we can now do char as well. So that means that when we're scanning, we could also utilize this value as well. If we take a look at here, I don't think we need anything else. We now have all the positions that we need, and we can validate this. So now we have this char available to us. Where do we want to include it? So in our case, maybe we need to build up a set of gears. So we actually know, like, we need to scan through every single one of them and identify whether or not something is a gear and if there's any numbers associated it. We're already scanning all of the numbers. I think we should utilize this for each function. In our case, what we can do is something like if, let's say, n is equal to a star or an asterisk, we need to do something. In our case, maybe we want to store a list of our numbers or something like that for this as well. So let's take a look. What we probably want to do is actually for every symbol. Oh, I'm gone the other way. For every symbol, we want to maybe create a list of gears associated this with this specific symbol. So in our case, we need more gears. Do we? You know what? We'll use another hash set as well. They're really great. We'll keep on using numbers as well. We'll create new hash sets per symbol. That's going to be really straightforward. Add this. Inside this now, we need to add all of these gears together. So we're going to add insert a gear. In our case, would be an N. Let's problem here. First things first is another clone. No, I'm not a big fan of cloning everywhere, but we'll just use it for now. Do two different types are being checked? Oh, of course, because it's actually the char in here. Checked against. Look at that. And okay, so it's a char pointed to a char. Yeah, fine. A reference to a char, and then we need to also make the other side a reference to a char as well. Fantastic. So now we are collecting all of these gears now. So if we go down here, let me so here now we can actually we have a list of these gears. So let's print this out and double check that's exactly what we have. Gears, and print this out as well. So if we run that now, we have now a list of gears. Let's here, maybe we'll move this away. And we can see here now that we have the first gears, we have a 32, then we have a 4, 6, 7, and then we also have another one here and another one here. But something I did notice, and pained me last time that I went over this, and thankfully I caught it this time a little bit sooner, is actually the ability that if you notice here in these brackets, it does actually say that if there is a number by itself, in the case of 617, we actually want to make sure that we do not include it inside our ratio. So you can't times it by anything else, so it's not included. So if we know that edge case as well, what we need to do is go back up here. We're going to add a if statement here. It will most likely be something like, I don't know, gears dot length is greater than 1. So if it's as long as it's greater than 1, then what we want to do is we want to create a result. What's that result? It's actually the multiplication of all of these ratios. Now, it could be 2 or it could be many. I don't know. My assumption is that there could be infinite amounts. So actually what we want to do is create a... we want to multiply all of these together. So in our case, what we want to do is we want to create a result. We'll set this to an I32 just so we know. And what we can do here is actually for every gear in our gears, let me make that a bit bigger. For each one of our gears, we want to iterate over it as well. We want to go over it with a map as well, provide it with a G. Let's G. Oh no, it's numbers, of course. A number just so it makes it a bit easier. Of course, we need to parse this value because it's not actually useful in its current state. Maybe at the top we're parsing it multiple times. It's probably time to have cleaned that up by now. We need to use the turbofish syntax there, and never forget the unwrap. The unwrap's probably an important thing. Now, the question that I went over last time was around how do I like times the previous thing and the current thing, or maybe the next thing and the current thing together. There's actually a lot of different functions in the Rust library to help with this. I actually was looking into this last time, and there's a ton of different methods you can use. But one of them that I think is really useful for this is actually there's a produce or a product like function. This will actually do exactly as what we just described. It will go over and times this next one with the previous one. Well, so it does pretty much the equivalent of like one times like that the end, all of them across. So we don't have to worry about anything like that. And then finally, with this result, what do we want to do with this result? If I go back over here, it actually says something along the lines of this needs to be summed together. So maybe what we can do here is in here, maybe we call this like gears or something. We'll store this value. I'm not going to change this how the scan returns. We're going to just create an I32 called gears, and we're just going to append this. So we do a self.gears, and then just add this result. That everything's well, everything's compiled. We'll go down here, do total. So this is total past part 1. We'll go into here and do gears. And we're going to put and we can't use this. I always think in Rust you can do like engine dots, but right now that doesn't actually work. You need to actually add this as a engine dot example here. And let's rerun that. So what we're looking for is this number. So 467,832, which is the same one as we have here. So let's try that now with the full file. Full, and rerun that. And here we go. We get the result of 67 million, and I'll leave the rest up, but we can actually see now this is the exact same as what we had earlier. So thank you very much for watching this. Next time, hopefully there won't be any technical difficulties, but I hope you enjoyed this anyway. I hope you have a great rest of your day, and join me for day 4 tomorrow. Take care.